All right, in this section we're going to be talking about exponential decay. Our learning targets are I can explain the difference between exponential growth and decay using word problems, a graph, and an equation, being able to see the difference in all of those. And then I can model exponential decay by graphing and writing an equation. Okay, so let's look at here at a real-world example of some exponential decay. Okay, so the NCAA holds an annual tournament, which is going on right now actually. The top 64 teams in Division I are invited to play. When a team loses, they're out. So our questions are how many teams are left after the first round of basketball games? So first we want to write a table and kind of start there, right? So I know that after having had no rounds, there are 64 teams left. Once I've had one round, I know that half of those teams are gone because they've all played, so I know that I've got 32 teams left. Then after 2 rounds, I know that all of these teams have played, so I have 16 teams left, right? And then if I was to continue this graph on and on, I would end up, right, half of these teams are gone, and then half again, and then half again, and then I have my winner. So this also, what I've just done here is I've kind of completed my table until only one team is left. So the next thing I can do is I can actually go down and plot these points, right? So after 0 rounds have been completed, 32 teams are left. So we're going to mark these off by 5s-ish. So we've got 5, 10, 15, 20, 25, 30, and 35. So after 0 rounds, I'm at 32. So right about there. After 1 round, I have 16 left, which is about there. Then I have 8. Then I have 4. Then I have 2. Then I've got 1, which is going to be really close here. So now you can see that I've plotted these points. Just these points that I've taken from up here are now plotted on my graph. And I could draw a line to kind of connect them, or draw a graph to connect them. It's not a line, but it's a graph. So now I can answer my other questions. How many rounds are played in the tournament? Well, there's 1 round, 2, 3, 4, 5, 6 rounds. And then let's look at number 4 here. Does this represent a linear function? No, it does not represent a linear function, right? Because remember, linear function is every time I go over an amount, I go up the same amount. And here, I don't do that. So this first jump that I did for this first round, I went down by 32. The second jump, I went down by a different amount than the first time. So that tells me that it is not a linear function. Okay, and so again, how does the number of teams left in each round compare to the number of teams in the previous round? This is half, right? So it's not a constant number, but it's a constant factor. That's what we're looking at with exponential decay. Okay, so again, this is back from that last section, right? Because we're using our same exponential function, which is a times b to the x, where x is a real number, right? A is not equal to 0, and then b is greater than 0. So here's the thing. We had our growth factor when we were talking exponential growth, where b was greater than 1. So we're looking at our decay factor here. So sometimes we think that this means that b is going to be negative, and that's not true. So this just tells me that b is going to be between 0 and 1. If you see a b value that's either a fraction or a decimal, that tells me that we have exponential decay. Okay, and here's kind of what our graph looks like. Again, my a value is where I start when I have a 0 as my exponent, and I'm decaying. So my graph is getting smaller. So here's an example. We're going to analyze this function. Without graphing, determine whether this function is growth or decay. So what I can look at is I know that this 14 right here is the a value. And I know that this decimal, the thing with the exponent, is my b value. So if b is greater than 1, then I know it's growth, right? Because that's what we talked about in the last section. If b is less than 1, but greater than 0, right? And I know that b has to be greater than 0. That's decay. So I see here that I have 0.95, and that falls into this, so I know that that is decay. Okay. So an asymptote. Here's just a vocab word that I want you to think about. An asymptote is a line that a graph approaches, but never actually touches. It gets infinitely close, but it never actually touches. So that's an asymptote. So here in example 5, we're going to be graphing our exponential decay. And I know that it's decay because my b value here is less than 1. Okay, so the first thing I can do is I make a table of values, right? And I use 0, because zeros make things go away a lot of times. And I pick a couple of values on the left of 0 and a couple of values on the right of 0. And I want to stick pretty close to 0 because when we're talking exponential functions, they get very big or very small very quickly. So I plug in my 0 for my x and I get 24. I plug in my 1 for my x and I get 12. I plug in 2 for x and I continue to fill out my chart. Then I go ahead and I plot those points, right? And you can see that yes, this does in fact model decay because the graph is getting smaller. So as x approaches infinity, right, as x continues, if I move my cursor back and forth along the x-axis, as x approaches infinity, so it keeps getting bigger and bigger and bigger and bigger and bigger, y approaches 0, right, because it approaches but never actually touches my x-axis. So I know that my asymptote, so the thing that my graph approaches but never touches, is y equals 0. Okay, and we want to think about this as if you were to take close your distance to the door by half. So between me and the door, I go halfway. And then I go halfway again and halfway again. You never actually will reach the door. So this is why we're approaching 0, but we never actually get there. Okay. So here now we're going to graph each decay function, and then I want you to identify the horizontal asymptote. So here I want you to go ahead and graph part A. Okay. So now we're looking at some more real-world connections about exponential decay. We see this a lot. So depreciation, right, is the decline in a value just from it being older or more wear. The real thing we see with depreciation is cars a lot. They depreciate very quickly. Okay, so here's this graph. We're told that this graph shows the expected depreciation over 4 years. So we're supposed to use this graph to estimate the value after 6 years. Remember, my decay factor equals 1 plus r, where r is the annual rate of decrease. Okay, so I'm given my initial value, right? At 0, my initial value is $20,000. After 1 year, my value is $17,000. So what I do is I go ahead and I kind of find my depreciation factor. Okay, so I know that in that first year I lost $3,000, and I have to divide that by what it was totally worth the whole time. Okay, so I take my final value minus my initial value over the initial value. So that gives me this beautiful negative 0.15. Okay, and I know to find my decay factor, just how we found the growth factor in our previous lesson, but to find a decay factor is 1 plus r. So my 1 plus r will give me a 0.85. This is going to be what I'm using to write my function. Okay, so I know that it decreases exponentially by this much each year. So again, I can plug in the numbers that I have. So I pick one of the points, right? So I like to, again, use my point at 0. So I know my y is at 20,000 at this point. We're going to use this point to help write our function. My a, I'm not really sure what my a is yet. I don't know what that is. I know my factor here, and my exponent is 0, so I can continue to solve. Right? And anything to the 0 power is 1. That's just an exponent property that I know. So that gives me my a. So now I can write my entire equation. And then I'm asked after 6 years, estimate the value after 6 years. So I go ahead and I plug in 6 for my exponent, and I evaluate and I simplify. So 6 years after I buy the car, it's worth approximately $75.40. Okay, so now you're going to go practice what we've done. So here's your homework. This is also in your calendar, so you'll have it in multiple places. You've got a couple of problems to do. Please, on these homework problems, show all of your thinking and all of the work that you do. And then you've got a couple of Khan Academy skills to wrap up our talk about exponential decay. So let's look at our learning targets real quick. I can explain the difference between exponential growth and decay using word problems, a graph, and an equation. Right? So the graph is the easy one to look at, because I know if the graph looks like this, that would be growth. If it goes down, it's decay. And the equation we talked about, looking at that growth factor, if it's greater than 1, then it's growth. If it's less than 1, then it's decay. So then I can model an exponential decay by graphing and writing an equation. So you're going to be doing some of this in your homework. So make sure that if you need help with that, you come back and watch this part of the video again